In this video, we're going to look at a related rates problem that involves an angle. It says a camera is positioned 4,000 feet from the base of a launch pad. The angle follows the rocket as it travels up. Assume the rocket rises vertically and at I think it's supposed to be 3,000 feet. Its speed is 600 feet per second. How fast is the angle changing at that moment? Okay, so we've got our rocket, and you guys already know I'm not that great at drawing. So I'm just gonna put this will be my camera. Okay, great. And our rocket is rising vertically, and as it's rising, the angle is following it. Okay, and I'm just gonna put a capital R for rocket. Okay, great. So what I know for certain is that the camera itself isn't moving. It's 4,000 feet. It's fixed. Okay. However, this side is moving and this side is moving. I'll tell you what. I'm gonna go like this for my rocket. Okay, and I'm gonna call this side R. All right, now. We could call this side X or Y or D or whatever, but I want you to notice that these are the two things that we've been given information about, is that this side and this side. And I want to measure how fast the angle is changing. So you want to think about Sohcahtoa. Okay, so if I look at this angle, I have opposite and adjacent. So the trig function that has opposite and adjacent is tangent. Okay, so for these problems, typically you're going to use tangent. So what I've got is the tangent of theta equals r over 4,000. Okay, so opposite over adjacent. Okay, great. We're going to take the derivative with respect to time, but before I do that, I want to remind you guys that when you have a denominator that's just a constant, you could push it to the side, and this is just a coefficient. That'll make finding the derivative a lot easier. Okay? All right, now we're going to take the derivative with respect to time. Okay, the derivative of tangent is secant squared, but I got to tag it with a d theta dt. Okay? The derivative of 1/4000th r is 1/4000th dr dt. Okay, what I want to solve for, my final answer that I'm looking for, is this guy. So that means that I need to plug in for this and this. So let's see what I've got. I know if I go back to that problem that at 3,000 feet, so when this is 3,000, this is traveling at a rate of 600 feet per second. Okay, so what I know then is at that moment in time, I know that r is 3,000, so this would be dr dt is 600. All right, awesome. So I know that this is 600. I got a problem though. How the heck am I going to figure out what secant squared of theta is? Well, remember that secant is the same thing as 1 over cosine. Okay. So can I go up to this triangle and maybe just use Sohcahtoa? Okay. So what I'm saying is that if I know that this is 3,000 and this is 4,000, then I can use right triangle of the square root of 3,000 squared plus 4,000 squared. And what you're going to get is this is going to be just equal to 5,000. Okay, so if I look up here at this moment in time that we've paused it, the cosine is adjacent over hypotenuse. So cosine of theta, let me write it right over here, would be adjacent over hypotenuse. So it would be 4,000 over 5,000. Well, let's just go ahead and just call that 4/5. Okay, so if I know that the cosine is 4/5, then I could just flip it upside down, or here flip it. So this would actually be, I'm actually going to do this differently. If cosine is 4/5, then that means that the secant is 5/4. I think that'll be a little bit cleaner. Okay, so I'm going to come down here and write 5/4 squared. Okay. All right, so to finish this off, all I have to do is multiply 600 times 1 over 4,000, and then divide this across, and when we do that, we will get the lovely decimal 0.096. Okay, now, this is a real number. A real number means radians per second. So the camera angle is changing at a rate of 0.096 rads per second. Now, if you want to geek out and you want to change this to degrees, which I totally get, remember that to convert from radians to degrees, you'd have to multiply it by pi over 180. I lied. 180 over pi. There we go. I make mistakes too. So if you multiply this by 180 over pi, you'll get 5.5 degrees per second. You don't have to take that step. I'm just saying that for those who are geeking out and saying, I want to know what it is in degrees, there it is. All right, there are a couple of problems in the homework that are like this. One is in a camera following a dragster, and one involves an elevator. So follow these steps. Good luck.